Welcome to The Explainer. Today we are going to talk about something that is pretty much everywhere. I mean, it's probably running on your phone, your computer, maybe even your smart fridge right now. We're talking about Java.
Okay, so you've definitely heard the name, right? But what is Java, really? Well, the answer is kind of cool, actually. It's more interesting than you'd think because it's not just one single thing.
See, Java has this really unique dual identity. It's a programming language, the stuff you write code in, but it's also the platform where that code actually runs. To get why that's such a big deal, we've got to rewind a bit.
So, to really appreciate why Java was a total game changer, we have to look at the world before Java and the massive problem it was built to solve.
Okay, so back in the day, if you were using a language like C++, it was pretty straightforward. You'd write your code, your source code, and then a program called a compiler would take it and translate it directly into what's called native machine code.
Now here's the catch. This native code, it's super specific. It only works on one type of computer. So the code you compiled for a Windows PC, totally useless on a Mac. And the Mac code wouldn't run on a Linux machine. You see the problem?
I mean, this was a huge headache for developers. Imagine doing all that work, and then having to do it all over again, and again, for every single different computer you wanted your program to run on. This is the exact problem that Java was created to fix.
So how did they do it? How did Java's creators tackle this mess? Well, they came up with an absolutely brilliant, elegant solution.
Here's the genius part. Instead of compiling that Java source code directly into native machine code for, say, a Windows PC, the Java compiler does something different. It translates the code into this special intermediate format. And this special format has a name, bytecode. The best way to think about bytecode is like a universal language. It's a neutral, in-between language that isn't for Windows, or Mac, or Linux. It's for everyone. Any computer can be taught to understand it.
Okay, that's great, but how? How do all these different computers learn to understand this new universal language? What's the secret ingredient?
Well, that brings us to the hero of the story, the Java Virtual Machine, or JVM for short. The JVM is basically a piece of software you install on your computer. Think of it as a universal translator. It sits on your Windows PC or your Mac or your Linux box, and its one job is to take that universal bytecode and translate it on the fly into the specific native instructions that your machine understands.
And that right there is what gave birth to the famous slogan that made Java a massive success. Write once, run anywhere. It's so simple, but so powerful. You, the developer, write your code just one single time,
And that one compiled file, that one piece of bytecode, can run on literally any device that has a JVM installed. Windows, Mac, Unix, it doesn't matter. No changes needed. It just works. Amazing, right?
So this JVM, this translator, it's really the core of what we call the Java platform. But the platform itself is actually a bit more than just that translator. Let's take a look. When we usually talk about a platform in computing, we mean the hardware and the operating system working together, like Windows on an Intel PC or Mac OS on an Apple computer.
But the Java platform is different. It's a software-only platform that runs on top of all those other hardware platforms. And that is what makes it so powerful. It creates this consistent protective layer, so your program doesn't even have to know or care what kind of computer it's actually running on.
So let's look at the layers. You have your Java program at the top. It only ever talks to the Java platform. And that platform, as we said, has two big pieces. There's the JVM, our translator, which we already met, and then there's another super important part, the API.
API stands for Application Programming Interface. The easiest way to think about it is like a giant pre-stock toolbox. It's full of ready-made software parts that do all sorts of common things. So instead of building everything from scratch, developers can just grab a tool from the API. It makes building software way, way faster.
Okay, so we've talked about the platform. Now let's just take a quick peek at the language itself. The actual blueprint that developers use to write the code in the first place.
The language was designed from the ground up with a bunch of key characteristics in mind. You hear these buzzwords all the time: object-oriented, robust, secure. The whole idea was to make it incredibly powerful and high performance, but also portable and simple enough that tons of programmers could get up to speed with it pretty quickly.
But how do you guarantee all this? How do you make sure Java is reliable and works the same everywhere? Well, it all comes down to the fact that it's built on an incredibly strict and detailed set of rules.
And those rules are all written down in one foundational document, the Java language specification. You can think of this as the official rulebook. It's the ultimate source of truth that guarantees that the whole write once, run anywhere promise actually works, no matter who makes the Java compiler or the JVM.
When you step back and look at it, Java's run anywhere idea truly changed software development forever. It was a revolutionary solution to a massive, nagging problem. And that kind of leaves us with a final thought, doesn't it? What huge nagging problem will the next great programming language solve?